Chemicals are indispensable, important to life on Earth, and vital for many processes affecting health, air, water, and land. Much of the products we use today are formed from combinations and reactions of chemicals. But chemicals aren't always helpful and safe. Hazardous chemicals and reactions have tremendous effects on human health, environment, social life, and many other aspects on Earth. Today, let's take a closer look at how ammonium nitrate affects us when its reaction goes wrong. To start off, what is ammonium nitrate? Ammonium nitrate has a chemical formula NH4NO3. It is a salt of ammonia and nitric acid. This substance is widely used for fertilization due to its high nitrogenous component. It is also commonly used in explosives and in mining because it serves as a concentrated source of oxygen to fuel the detonation. It is relatively inexpensive to manufacture and very stable under safe conditions, making it a popular choice for fertilization and bomb making. NH4NO3 is a solid crystalline salt. It's colorless and odorless and has a melting point of about 169.6 degrees Celsius. It also has a high boiling point at about 200 to 260 degrees Celsius. It is highly soluble in water, and its pressure in water is about 2.3 kPa at 20 degrees Celsius. In a concentrated solution, it has a pressure of about 1.5 kPa. Ammonium nitrate is an oxidizer and an irritant, both of which we will get into soon. So how does ammonium nitrate look under normal conditions? Solid ammonium nitrate is often shipped and stored for its various uses. It's stored as pearls, which are a pelleted form of the substance, making it easier for shipping and handling. It's most commonly used as an artificial fertilizer because of its high nitrogen component, which increases growth and crop yields. It's often used in explosives and detonators for mining as well. When combined with fuel oil, together known as ANFO, it allows for fast and easy combustion reactions. The substance will decompose non-explosively in water and produce stable amounts of gas. Let's look at a few normal reactions of ammonium nitrate. The first one is the synthesis of the substance. Ammonia, NH3, reacts with nitric acid, HNO3, to produce solid ammonium nitrate, NH4NO3. During this reaction, ammonia is in a gaseous form and reacts with the concentrated nitric acid. The product is a solid salt of ammonium nitrate. The reaction is often violent and thus takes place industrially. So if ammonia and nitric acid make ammonium nitrate, let's determine what the limiting region in this reaction is. The limiting region is the reactant that will be used up first, and therefore limit or complete the reaction. In our case, if 100 grams of both ammonia and nitric acid were used, it is found that nitric acid will be the limiting region, meaning this substance will control the amount of ammonium nitrate that is produced. The other major reaction that takes place with ammonium nitrate is its decomposition. When exposed to temperatures near its boiling point, about 230 degrees Celsius, ammonium nitrate will decompose into nitrous oxide and water vapor. Under this temperature mark, normal decomposition occurs in solution and can be controlled. Often, ammonium nitrate is melted in water to be used in fertilizing processes. The decomposition reaction may also produce other products of nitrogen oxide. Here are the various other products that may be formed when ammonium nitrate decomposes. Okay, so we've looked at how ammonium nitrate reacts under normal conditions, but how do these reactions go wrong? Let's look at ammonium nitrate in hazardous conditions. NH4NO3 is an oxidizer, meaning it removes electrons from other substances easily and increases the burning of fuel by providing it excess oxygen. By itself, the substance is not explosive or harmful. It only becomes unsafe when contaminated with combustible materials and near high temperatures. When it decomposes under these conditions, it will rapidly produce toxic nitrogen gases and oxygen, which will increase the explosive capacity of the nearby combustion reaction. The following are favorable conditions for a hazardous ammonium nitrate reaction to take place in: temperatures greater than 260 degrees Celsius, a high concentration of the substance, meaning there is a higher concentration of oxygen available for the combustion reactions, contaminated with highly combustible materials or placed in such environments, and confinement during storage. Here is an example of the decomposition reaction that may take place under the conditions listed previously. The most common products are nitrogen gas, oxygen gas, and water vapor. Now, what are the results of a hazardous reaction and what will it damage? First, let's look at ammonium nitrate hazards when it is still a stable substance. Although the substance is rarely harmful in normal conditions, inhalation of high concentrations can cause respiratory tract irritations, including cough, sore throat, suffocation, and more. If ingested in high amounts, there are a multitude of possible symptoms and adverse effects, including mild ones such as headaches, dizziness, and vomiting, to severe effects including convulsions and suffocation. Under hazardous conditions, such as near combustible materials or when exposed to high temperatures, NH4NO3 will rapidly decompose into various gases and fuel a nearby fire or combustion reaction. As these gases are released, a violent explosion may take place. During this reaction, toxic nitrogen oxides are released into the atmosphere, which may cause severe respiratory irritation and even prove to be deadly. For example, the reddish pigment in the explosion of the first picture is from nitrogen dioxide, a highly toxic gas. Ammonium nitrate explosions are quite rare, as it requires a high degree of combustible contamination and high temperatures to explode. However, here is a timeline of accidental explosions in the past. The ones in blue circles include ammonium nitrate as the major explosive material. As you can see, 4 out of 11 of these explosions had connections to NH4NO3, most of which had disastrous results and damages. Now, let's take a closer look at one of these explosions, the most recent one in Beirut, Lebanon, of this year. On August 4th, 2020, a massive ammonium nitrate explosion rocked the Lebanese capital. 3,000 tons of stored ammonium nitrate at the city's port allegedly exploded due to a nearby fire, as seen in the visual here. There were over 202 casualties as of now and about 6,500 injuries. Property damages are estimated to be around 15 billion USD, implementing a tremendous economic strain on the city. Moreover, 300,000 people are now left homeless. The main cause of the explosion and the fire is still under investigation. However, it is significantly blamed on the negligence of port officials that were monitoring the storage of the substance. The damage of the Beirut explosion is still paying a heavy toll on the city. The explosion occurred amidst an ongoing civil unrest, a socioeconomic crisis, and the COVID-19 pandemic. The economy of the city and the country overall is very weak, and it requires substantial aid to reconstruct and clean up the damage. As mentioned earlier, an ammonium nitrate explosion releases nitrogen dioxide. So due to the massive scale of this explosion, tons of nitrogen dioxide and other toxic gases were released into the atmosphere, causing significant damage to human health and increasing pollution in the infected area. As for politics come in for the blame of the explosion, civil unrest increases in the city. The aftermath of this blast is commonly compared to the aftereffects of the atomic bombing of Hiroshima in the Second World War. Due to the country's ongoing economic crisis, international aid is essential for its recovery and cleanup. Organizations like WHO and foreign allies like France, Turkey, and Egypt are sending personnel and supplies to help the city recover after the massive damages. Amidst the pandemic, supplies and restrictions have been placed. However, the city is still struggling as hospitals are damaged in the blast. Beirut has thus seen a spike in COVID-19 cases in the past 2 months. On the upside, reconstruction has now started in the city. Even though such disasters are rarely frequent, it is still important to consider and implement safety measures to prevent any accidents. Here are some preventive measures that can be taken by storage facilities and owners of ammonium nitrate. Firstly, avoid heating NH4NO3 in confinement. Keeping such high concentrations in tight spaces is a hazardous condition that can increase the intensity of a blast. Avoid introducing heat in localized areas where NH4NO3 is stored. If enough heat is available, the substance will rapidly decompose. Avoid contamination of combustible materials such as oils and waxes. Avoid contamination with materials that can easily combust or explode, such as metals and chlorides. Finally, avoid low pH conditions because acidity will contribute to higher explosive capacity. Finally, let's look at what regulations are in place that monitor and regulate ammonium nitrate. Due to its high explosive capacity and possible threat to civilian life, most countries have some sort of regulation on the substance. For example, it's banned in countries such as Australia, Germany, Ireland, Pakistan, and the United Kingdom. In other countries, it is classified as an explosive and is tightly restricted, including Canada, India, and the United States. The Canadian government passed tight regulations in February of 2008. These include, but are not limited to, the following rules. Anyone purchasing the substance must present appropriate ID. One cannot buy more than is proportional to their needs, and the seller must record the buyer's info. Most destructions and explosions in the past have been caused accidentally, either due to hazards in storage or negligence, or through terrorism. It's quite simple for someone to buy a couple hundred kilograms of ammonium nitrate and use it to detonate a bomb if there aren't already any restrictions in place. Hopefully this presentation has given you a better idea of how normal reactions can go wrong due to just a few unsafe conditions. Here are the references that were used to collect information. Thanks for watching.